Hello, in this video we're going to go over solution to exam 4 in my multivariable calculus course in spring of 2024. Let sigma be the sphere given by rho equals 2, which means it's a sphere centered at the origin, and the orientation is also given as inward orientation. And they're asking us to find a surface integral using an appropriate theorem. Okay, so first we're going to draw the diagram, and we called this surface sigma. What would be an appropriate theorem to use for evaluating surface integrals over closed surfaces? Well, clearly that would be the divergence theorem. But first we have to identify the interior of this. So let B be the ball of radius 2 centered at the origin. So we will apply the divergence theorem. So by the divergence theorem, and they also instructed us to name the theorem. So by the divergence theorem, we would get the given surface integral of x squared minus e to the y z I plus z to the fifth minus 2xy j plus z plus y squared k dot n ds. Because the orientation that they gave us is inward, we'll need a negative sign. So that would be negative triple integral over the ball of divergence of this. So we'll have to take the derivative of the first one with respect to x. So that would be 2x. Derivative of the second component with respect to y. That would be minus 2x. And derivative of the third component with respect to z. And this is going to be triple integral over b of 1 dv, which is the volume of b. So what is the volume of a sphere? It is 4/3 pi r cubed. And this would be 32 pi over 3. Okay, so let's move on to the next problem. Let sigma be the portion of the paraboloid. So z equals 1 minus x squared minus y squared is the given paraboloid. The vertex of this paraboloid is at 0, 0, 1, and it is downward. So this is our paraboloid. They said portion of the paraboloid that is above the xy plane oriented downward. So this is our sigma, and the orientation is downward. Oh, and for the previous problem, I forgot the negative sign. So we'll have a negative sign here, and this would be negative 32 pi over 3. Okay, so sigma is given as oriented downward, and they asked us to use the Stokes theorem to evaluate this surface integral. So we are given a surface integral of a curl. We have to switch from that surface integral to a line integral. So we have to first identify the boundary of this. So what is the boundary of this? The boundary is this curve right here. So if I call that C, and we're going to have to use the right hand rule to orient this C. So C is the boundary of sigma oriented clockwise viewed from above. So that would be our sigma, our C, and then we can use the Stokes theorem. So the surface integral of curl f dot n ds is going to be the line integral of f dot r. So this is the Stokes theorem. And they said turn this line integral into a definite integral, definite single integral, perform all calculations, but do not evaluate the final definite integral. So first thing we need to do is to parametrize this C. So what is C? C is given by x squared plus y squared equals 1, which means r of theta is going to be cosine theta, sine theta, and 0. And theta ranges from 2 pi to 0. Why? Because it is clockwise when viewed from above. So now we can take the derivative of this to get dr. So r prime of theta is going to be negative sine theta, cosine of theta, and 0. So this line integral that they gave us is going to be integral from 2 pi to 0 f. We'll have to take f, plug in the parametrization into f. It would be cosine x theta, so x plus y, so cosine theta plus sine theta I, plus, or rather minus, z minus y, so z minus y j, so it's x plus y I minus z minus y j plus e to the z plus e to the 0 plus x, which is cosine of theta k, and we'll have to find the dot product of that with r prime of theta, so minus sine theta cosine of theta 0 d theta. So let's make sure we did this one right. So e to the z, which is 0 plus cosine of theta. Okay, so now we'll have to find the dot product, and that would be our final answer because they asked us to not evaluate. So dot product would be the product of cosine theta plus sine theta and negative sine theta plus, this is sine theta times cosine of theta, and finally e to the 0 plus cosine theta times 0. So that's 0. So all of that d theta. So this is our final answer. And they asked us to not evaluate this. Okay, so let's look at number 3. Consider the vector field this without finding a potential function. Show that f is conservative. So how do we show this is conservative? We'll have to show two things. First, curl is 0, and second, it is defined over the entire plane. This is a two-dimensional vector field. So f is defined over the entire plane. So that's one condition. And the second thing is we have to also evaluate curl and show that the curl is 0. So we'll go ahead and evaluate the curl. So partial with respect to x, partial with respect to y, partial with respect to z. So what is the x component? It is 1 plus 3x squared y plus 2yx. So I may have to move this one a little bit further. Second component is x cubed plus x squared, and third component, because it's in two dimension, is just 0. And next we'll have to just go ahead and evaluate this. First component becomes derivative of this one with respect to y, 0 with respect to y, minus derivative of this one with respect to z, so that's that, minus, eliminate the second column, we get 0 minus 0j, eliminate the third column, we get 3x squared plus 2x minus 3x squared minus 2xk. And this is 0. So we check both those two things. That tells us that f is in fact conservative. Okay, so next is find a potential function for this f. So we'll go ahead and evaluate the potential function. So we need this. We need f sub x to be the first component, f sub y to be the second component. So the first component is 1 plus 3x squared y plus 2yx. And the second component is x cubed plus x squared. So what does this mean? We can evaluate f by integrating them with respect to x, x plus x cubed y plus yx squared plus h of y, some function of y, because we are in the two-dimensional case, there is no z here. We take that and plug it into the second equation. So if I plug it into the second equation, I would get x cubed plus x squared plus h prime of y equals x cubed plus x squared. So that tells us h prime of y is 0, which means h of y equals 0 works. So this is one potential function. So a potential function, So this is 1 h of x, which gives us a potential function. So a potential function is going to be f of xy equals, let's go back and see what we got. We got x plus x cubed y plus y x squared. So this is a potential function. And finally, they said evaluate the line integral. So what is the line integral? Well, we simply have to plug in the endpoint. So the line integral of f dot dr, because we don't even know what the curve is. They said C is an unknown smooth curve from 1, 0 to -1, 1. So we take the terminal point, which is -1, 0, I believe. -1, 0 is the terminal point, and the initial point is 1, 0. We plug those in and we subtract terminal minus initial. So let's do that. When we plug it into f of -1, 1 becomes -1 plus -1 cubed times 1 plus 1 times -1 squared. That's f of -1, 1 minus f of 1, 0. So that would be 1 plus 1 cubed times 0 plus 0 times 1 squared. So this would be -1 minus 1 plus 1 minus 1. And the rest is going to be 0. So that's -2. So that's the answer. Okay, so the last problem. Let C be the curve of intersection of the cylinder x squared plus y squared equals 4. So we'll go ahead and draw the diagram for this. And, okay, so this is x squared plus y squared equals 4. And the hemisphere z equals root. So the radius of this one is, radius of um, this cylinder is 2. The hemisphere has a radius of root 5. So if you square both sides, you get root 5 for the radius. So it's a little bit larger. So you have something like this. And this is z positive. Okay, so let's C be the curve of intersection of the two. So the curve of intersection would be something like this here. So the first thing we need to do is to figure out what is this curve. Okay, the hemisphere this, and the question is the mass density of a wire positioned at C at every point is the distance from that point to the origin. Write down the line integral that is equal to the total mass of this wire. Turn this line integral into a single definite integral. Do not evaluate. Okay, so first thing we have to do is to find out what is the equation of this C. So C is the intersection of these two. X squared plus y squared equals 4 and 5. And z is root 5 minus x squared minus y squared. If we plug that in here, we get z equals root 5 minus 4, which is 1. So what does it mean? It means c is given by x squared plus y squared equals 4 and z equals 1. So that gives us the parametrization. So r of theta is going to be 2 cosine, 2 sine, and 1. So this is the parametrization for r. Now, what is the total mass? They said the density is the distance to the origin. So they said the distance to the origin. So the total mass is going to be line integral over this C of the density, which is root x squared plus y squared plus z squared ds. So this is the total mass. Now, in order to evaluate this one, we'll have to change everything to theta. So this would be root x squared plus y squared. We know on that curve, x squared plus y squared is 4, and z squared is 1 squared, and then ds. ds would be magnitude of r prime, which would be minus 2 sine theta, 2 cosine theta, 0 d theta. They ask us to turn this line integral into a single definite integral, but do not evaluate the integral. Okay, so that's going to be integral from 0 to 2 pi root 5 root 4 sine squared plus 4 cosine squared d theta. which is integral from 0 to 2 pi. This is 2 root 5 d theta. So we don't even have to evaluate that, but it's actually pretty straightforward to evaluate. The second part of the problem is asking us to find a line integral of a vector field when C is oriented clockwise when viewed from above. Okay, so the line integral of xi plus xj minus k dot dr. Because the orientation is clockwise when viewed from above, theta would go from 2 pi to 0. So 2 pi to 0, x is, so they said perform all operations but do not evaluate the integral. So what is x? X is 2 cosine. We already did the parametrization. And so we can put it here, 2 cosine j minus k dotted with the derivative, which is minus 2 sine theta 2 cosine theta 0 d theta. And then we'll have to perform the operation. So 2 pi to 0. When we do the dot product, we get minus 4 cosine theta sine theta. And then the second component gives us plus 4 cosine squared theta. And the last component is 0. So that is the final answer to this problem.